Let's take a look at practice quiz number 11 on probability and inference. So number 1 says determine if each of the following situations is a binomial distribution, and if it does or follows a binomial distribution. If it does, explain why each condition is met, and if it does not, say why each condition was not met. So for number 1, I see it says I flip a coin 10 times and count how many times I get heads. So number 1, there was a set number of trials, we call it, because we flip the coin 10 times. That's a set number of trials. Number 2, each flip has the same probability. And then number 3, there are 2 outcomes is what we're looking for. So I get heads or tails. So 2 outcomes. So those are the 3 things that we're looking for. So that one does qualify as a binomial distribution because all 3 of those conditions were met. So number 2 says I shoot 8 free throws and get coaching after the 3rd free throw. So number 1, there was a set number of trials of 8 free throws. So that's good. Number 2, though, each free throw would not have the same probability because there was coaching after the 3rd. So each free throw, I'm just going to make this short. Let's just say probability varies because that's a shorter way to say it. So this is a no for that reason. And number 3, there are 2 possible outcomes, so that was fine. You either made it or you missed it. So the only problem was the probability would change on that 3rd free throw where you had coaching, and then every throw after that. So number 3 says I roll a die 100 times and I count how many times I get a 4. And so for this one, there is a set number of trials, the 100. So that is good and that is true. Number 2, each roll would have the same probability. So we'll just write same probability. But number 3, there's not 2 outcomes because a die has 6 sides. So die has, or we can just say to make it consistent, more than 2 outcomes is all we really need to say. So this one is a no for that reason. All right, number 2 says Shari reads in a magazine article that 86% of teenagers prefer sweatpants over jeans. She decides to test this, so she takes a simple random sample of 100 people at the local grocery store on a Saturday afternoon. And she wants to know what is the probability that she finds exactly 75 people who prefer sweatpants. And so that would mean, first of all, we see that this is a binomial distribution. Either they prefer sweatpants or jeans. There's the same probability for each person, and there is a set number of trials of 100 people. So we're good with that. So we're going to type in our calculator binom PDF because we want an exact number. We're going to type in the number of trials, which was 100 people. Each person would have an 86% chance, and we know exactly 75 people is what we're looking for. So those are the values we're going to type in our calculator. So let me pull this up. So we go to second vars, which is right beside the clear button. That's our distribution menu. And then go to binom PDF and type in the 100. And then my screen makes me type a comma, but some of your calculators look a little different, but they work the same way if they're a list or if it needs some commas. So we enter all of that and we get 0.0013 is the probability. You can just leave it like that, or if you do want to make it into a percentage, which is not really necessary, you could move your decimal point over and say 0.13%. Both are just fine. B says, what is the probability that she finds fewer than 75 people prefer sweatpants? So fewer than 75 people, she wants the probability of 1 person, or 0 people, I should say, up to 74, because she wants less than, like fewer than 75. So you got to think ahead of what number do I need to type in. So I'm going to type binom CDF because I want a range of probabilities. I'm still going to ask 100, or Shari's going to ask 100 people, I should say, their probability of liking sweatpants is 0.86. And then our last number, you have to think through, like I said, of what do you need that last number to be. But in this case, it's 74 because we want fewer than 75. So that would mean it cuts off at 74. So let's type in second vars binom CDF 100, comma 0.86, comma 74. And it's still a small number, but that's fine. That's just what we got. So 0.0011. And again, you don't have to move the decimal and make it into a percent, but if you did, it'd be 0.11%. And part C says, what is the probability that Shari will find more than 80 people who prefer sweatpants? So more than 80 means you don't want the 0 probability up to the 80. You really only want the numbers that are after that. So like 81 and up. So what we have to ask our calculator to do is subtract out the probabilities of those lower numbers and only leave us with the rest, the 81 to the 100. So we need to say 1 minus binom CDF. We're still asking 100 people. They still have 86% probability. But then we want to put in 80 is the last number that we don't need the probability of. So that's why we're subtracting it from the 1. Because it's like 100% minus this probability. So second vars binom CDF. We still have 100, comma 0.86. And now we need our last number to be 80. Oops, I don't need the plus sign. And so we get 0.939 approximately. And you can definitely just leave it like that because they do. Or if you did need to move it over to make it a percent, it would be 93.9%. All right, on to number 3. The incubation time for chicks is normally distributed with a mean of 25 days and a standard deviation of approximately 2 days. If 600 eggs are being incubated, how many chicks do we expect will hatch in 19 to 21 days? So what I'm going to do is go to Desmos, because normal distribution, we need Desmos. And I'm going to go to functions, and I'm going to scroll down to distributions and pick normal distribution. And I'm going to type in the mean that they told me. So the mean was 25 days. And the standard deviation they also told me is 2 days. So first I put mean and standard deviation, but then I want the cumulative probability from 19 to 21. So I'm just going to put 19 for the minimum and 21 for the maximum. And then that gives me the probability, but then I had 600 eggs being incubated. So the probability is 0.0214, but to get the number of eggs, I need to multiply by the 600. So I'm going to do 600, and then I'm just going to carry out this decimal a little ways. So it gives me a pretty good estimate. So I get about 12.8. So I would round to the nearest egg since we can't have part of an egg. So 13 eggs for part A. B says in 21 days or more. So that means 21 is the minimum, and you don't have a maximum, so just leave it empty. And so 21 days or more is a probability of 0.977, and then multiply that by 600. So in my calculator, I'm going to say 600 eggs times a probability of 0.977, and then you can just carry it out a little further. And let's say we round to the nearest egg, it's about 586 eggs for that one. And then 21 days or fewer, so 21 has to be your maximum and no minimum. And that probability is 0.023. And then we multiply by 600, but I just always like to push out the rounding a little further with my calculator. So let's see, 0.02275,013. And it looks like it's approximately 14 eggs. So that being said, I'm actually going to change these little symbols to be approximate symbols since we rounded. All right, so that's it for number 3. Let's take a look at number 4. Clear out my Desmos. Let's see. So number 4 says the average heights of third graders in the U.S. are normally distributed with a height of 50 inches and standard deviation of 3 inches. Draw the normal curve and find the following. So I have added a curve for you so that you don't have to worry about drawing it, just so. And so we have a mean height of 50 inches. So always put the mean smack dab in the middle. And then a standard deviation of 3. So that means you need to add 3 to the right. So plus 3 would be 53, plus 3 more would be 56, and plus 3 more would be 59. And then subtract 3 on the left. So 50 minus 3 is 47. 47 minus 3 is 44. And 44 minus 3 is 41. Then it wants to know, between what two values do approximately 68% of heights of third graders? I need to fix that. Sorry about that. So where do 68% of our data lie? So 68% always lie within 1 standard deviation from the mean. So between 47 and 53 inches, we always know between 1 standard deviation above and below the mean, there's 68%. So we would want to write down, technically it comes from 50 plus or minus the 3, which is 47 to 53 inches for the height of the third graders. Between what two values do approximately 95% of the data fall? So that is the second standard deviation away from the mean. So we would say, but within 2 standard deviations from the mean, 95% of our data is there. And to actually calculate that, we can say 50 plus or minus 2 standard deviations, which is 6, which gives us the 44 we've already calculated to the 56. You can just look at your picture for that. And so that's the answer to part B. And then between what two values do approximately 99.7% of the data fall? So we would say between the last ones, the farthest ones out, within 3 standard deviations, we have 99.7% of our data. And so we can write out that 50 plus or minus 3 standard deviations, which ends up being 9, gives us 41 to 59 inches. So between those two heights, we would have 99.7% of our data. All right, one more question to go. Jamie and Amy are married and both work for a coastal company. Jamie works in a department for which the mean hourly rate is $18.80 and the standard deviation is $3.20. Amy works in a department where the mean rate is $17.50 with a standard deviation of $2.80. Relative to their departments, who is better paid if Jamie earns $19.75 and Amy earns $19.15? So in order to compare the two different departments, we need our z-score formula, because that is how we compare two different types of measurements. So we can say z equals x minus the mean divided by the standard deviation. And then we'll set up one for Jamie and Amy and calculate. So let's pick out all the information we need for Jamie. So Jamie earns $19.75. So that's the x value. Minus the mean. So for Jamie, the mean rate was $18.80. Then divided by the standard deviation, which was $3.20. Then Amy, let's pick her information out, earns $19.15 an hour. Amy's mean was $17.50. And the standard deviation was $2.80. All right, so let's find the z-score and then we can compare. So I'm going to group the numerator together so I can type it all in at once. So I'm going to type 1975 minus 1880 all divided by 320. And I get 0.297. Okay, so then let's calculate Amy's. So we have 1915 minus 1750, and then all divided by 280, and we get 0.589. So relative to their departments, we can see that Amy is higher paid than Jamie because Amy is more standard deviations above the mean compared to Jamie. So I'm just going to write a conclusion. So we know that Amy, relative to her department, so in comparison, she is paid more because she fell let's say 0.6 standard deviations. We'll round that off. Standard deviations above the mean compared to Jamie, who only fell still above the mean, but 0.3 instead of the higher number. 0.3 standard deviations above the mean. So let me make sure that makes good sense. Amy, relative to her department, is paid more because she fell 0.6 standard deviations above the mean compared to Jamie, who only fell 0.3 standard deviations above the mean. All right. So that is it for practice quiz number 11.